El Nino Southern Oscillation lesson. In this lesson, we'll look at the science and engineering practices of developing and using models. Cross-cutting concepts will include patterns, systems and system models, and stability and change. So what is the El Nino Southern Oscillation? ENSO stands for El Nino Southern Oscillation. It refers to all changes in water temperature and sea level air pressure in the Pacific Ocean. Temperatures in the Pacific Ocean oscillate or swing between extremes. This cycle is the way in which Earth maintains natural equilibrium or balance between these extremes. Changes in ocean surface temperature disrupt air currents and pressure systems, which can affect weather patterns around our planet. El Nino and La Nina. Normally, the Pacific is warm in the west and cool in the east. The ENSO cycle includes both warming and cooling events. El Nino occurs when warm water builds up in the west and it moves eastward. This warms the surface waters of the Pacific. La Nina occurs when cool water from the east moves west, cooling the surface waters of the Pacific. El Nino and La Nina are part of the Earth's way of maintaining temperature and pressure equilibrium in the Pacific Ocean. El Nino means the Christ child. It was so named by the Peruvian fishermen who first noticed the phenomenon. The fishermen used this name because El Nino occurs during the winter months, around Christmas time. It occurs about every 2 to 7 years. Normal conditions. Normally, strong Pacific winds move cool water from eastern equatorial regions to the west, where the water is warmer. Because warm water takes up more space than cold, the western Pacific is usually about half a meter higher and 8 degrees Celsius warmer than it is in the east. Scientists define ocean temperature differences with an imaginary line called a thermocline. This marks the divide between warm upper ocean layers and the cold deeper water. Under normal conditions, the thermocline is deep in the western Pacific and shallow in the east. The thermocline is used to define the difference between two distinct layers of ocean water. The upper mixed layers are warmer and generally maintain a similar temperature to the surface water above. Below this, the deep ocean layer is much colder. In both these regions, temperatures are relatively homogeneous. Between these two regions is the thermocline, a transition layer that separates the warm and cold layers. Therefore, a shallow thermocline means that cold water is close to the surface, while a deep thermocline means that the upper mixed layer of warmer water is very deep. As a reminder, warm water takes up more space than cold water because its particles are moving faster and are farther apart. This makes it less dense. It should be important to recognize also that Pacific winds are not the only factor affecting ocean movement and temperature. The Coriolis effect, the movement of polar ocean currents, and upwelling all play integral parts in temperature distribution in the Pacific Ocean. El Nino conditions. During an El Nino event, the westerly winds weaken, allowing warm water to move east, heating the surface waters off the coast of the Americas. The thermocline flattens as surface temperatures grow warmer across the Pacific. Upwelling no longer brings cold water to the surface. These temperature changes disrupt normal air and ocean currents. El Nino ends when the Earth's rotation naturally moves water away from the equator. This brings cold water closer to the surface and strengthens westerly winds once more. Ocean water naturally moves away from the equator due to the rotation of the Earth. As surface water moves away from the equator and into the northern and southern hemispheres, colder water is brought to the surface. This process is called equatorial upwelling. Coastal upwelling occurs at certain coasts, such as the Pacific coast of the U.S. Here, surface water is pushed away by coastal winds, and deeper water is forced to the surface. This process contributes to the cooler waters in the eastern Pacific. Formation of El Nino. The El Nino is a natural event that affects ocean temperatures and pressure systems in the Pacific Ocean. Under normal conditions, the western Pacific Ocean is much warmer than the east. This temperature difference can be represented by imagining the location of the thermocline. The upwelling of ocean water, deep ocean water, at the coast of the Americas brings cold water to the surface. Air and ocean currents move this cold surface water west. As the water travels across the ocean, it is warmed by the sun. Air and ocean currents are linked. Cold water produces low-lying, high-pressure wind currents. Warm water creates higher, low-pressure wind currents. The cold, high-pressure currents help move the surface water from east to west. As the ocean and wind currents push surface water west, warm water piles up in the western Pacific, raising sea levels in that location. El Nino occurs when westerly winds weaken, reducing the westward movement of cold surface water. Warm surface water from the west is able to move east, flattening the thermocline and warming ocean surface temperatures. Upwelling continues in the east, but the layer of warm water is so deep that the cold water is no longer brought to the surface. Without cold surface water, air pressure distribution changes, disrupting wind currents across the Pacific. The El Nino cycle involves massive changes to ocean temperature, air pressure systems, and wind currents. These changes cause ripple effects that influence weather around our planet. Changes in weather patterns. Warm ocean surface water adds heat and moisture to the air above it. This warm, moist air rises, producing areas of low pressure at ground level. Oftentimes, this produces thunderstorm activity. Cold water cools the air above it. This cool, dry air tends to sink, creating areas of high pressure. Areas of high pressure have no precipitation. An El Nino event changes the distribution of warm and cold water in the Pacific. thereby changing the high and low pressure areas in the atmosphere. These changes influence the wind patterns, or the jet streams, that affect the weather around our planet. Impacts on weather. The redistribution of high and low pressure systems caused by an El Nino event can cause major changes in global weather. In general, El Nino causes increased precipitation in western South America, Central America, and the southern United States. Temperatures are higher and precipitation is lower in the northern United States and also in Canada. There are oftentimes below average precipitation in Africa, Asia, and Australia, which can result in serious droughts. Impacts on societies. Peru and some of its neighboring countries often received the first and worst effects of El Nino. Increased precipitation causes flooding and landslides, which can destroy entire villages. Disruptions in the upwelling of deep, nutrient-rich water kills the anchovies that inhabit that portion of our Pacific Ocean. This is a major staple of the Peruvian economy, and as such, it leads to major interruptions. In 1982, one of the worst El Niños on record occurred. Major floods and landslides swept the western coast of the Americas, while droughts led to a loss of crops and even famine in Africa, India, Asia, and Australia. Another major El Nino event that happened during the 20th century occurred in 1997. Like the 1982 event, it caused droughts and floods around the world, resulting in widespread famine, mud flows, landslides, and even wildfires. Both of these El Nino events left thousands dead and many more homeless. So let's complete the sentences about the El Nino Southern Oscillation. Warm water causes the average sea level to increase. Under normal conditions, the Pacific Ocean is warmer and higher in the west. Warm water in the eastern Pacific means it is an El Nino year. El Nino causes the thermocline to become flatter. Warm water produces low pressure, which causes more precipitation. El Nino causes droughts in countries west of the Pacific. And finally, an El Nino event begins when westerly winds weaken. So let's look at the stages of El Nino and sequence them. Step 1, westerly winds weaken across the Pacific. Step 2, warm water build up in the western Pacific and it moves east. Number 3, ocean surface temperature is warmer across the Pacific. Number 4, upwelling no longer brings cold water to the surface. Number 5, the change in ocean temperatures affects air pressure. And finally, number 6, air currents are redirected around the globe.